Hey everyone, and welcome back to the deep dive. Uh, today we're doing something a bit different. We're not just reading from a textbook. Instead, we're using insights from PCNSE exam, practice questions, and explanations. It's kind of a unique way in, actually. We want to really dig into the practical side of network security. The real nuts and bolts in complex enterprise setups. Think of it like a shortcut, maybe, helping you grasp how these big networks are actually secured on the ground. We think you'll get some really fantastic insights into the kinds of challenges pros face daily. Okay, let's unpack this.
Yeah, and what's fascinating here is, like you said, we're moving past just abstract ideas. These practice questions, they're almost like little case studies, right, from the front lines. They really force you to think about actual scenarios and the specific actionable knowledge you need. And just for context, the PCNSE exam itself, that's the Palo Alto Networks Certified Network Security Engineer exam. It's 80 minutes, roughly 75 questions, multiple choice, multiple select, costs about 175 USD. It's pretty rigorous. And understanding the why behind the answers, not just memorizing them, well, that's where the real learning happens. That's where you build expertise.
Exactly, and that's what I find so interesting about this approach. Each question isn't just, a test question. It's a peek into a real common challenge. It's like getting to look over the shoulder of a firewall admin making those key decisions.
So let's kick off with a pretty classic remote access scenario. Imagine an admin setting up GlobalProtect, that's Palo Alto Networks' remote access solution, right? Connecting users securely from anywhere.
Hmm.
Standard stuff for remote workforces.
Right, and the company policy is strict. All remote users have to use a specific two-factor authentication method, no exceptions. So the big question for the admin is, where exactly in GlobalProtect do they set up that authentication profile to make sure it applies to both the portal and the gateway?
Okay, yeah, this is fundamental, really securing that front door for GlobalProtect. The GlobalProtect portal, you see, that's the user's first point of contact. It handles their login, the authentication piece, and then points them to the right gateway. So to enforce that mandatory two-factor auth, you've got to configure it right there in the portal configuration. Specifically, it's under GlobalProtect portals, portal configuration authentication. It's all about locking down that very first handshake, before they even get near the network itself. Get this wrong, and well, your 2FA just isn't enforced. Could be a serious gap.
That initial handshake really is crucial, isn't it?
Yeah.
It just shows how precise you need to be with these settings. Get step one right. Okay, now let's think bigger scale. Managing security across lots of firewalls. So an engineer is using Panorama, that's the central management system from Palo Alto Networks.
Right, for managing fleets of firewalls.
Exactly.
Yeah.
And they need a new security policy, but, and this is key, it's only for one specific firewall model. And critically, it must not affect any other firewalls, even if they're in the same device group. How do you get that kind of surgical precision with central management?
This is a great question. It highlights a really important flexibility in Panorama because while it's all about centralizing policies, you absolutely need ways to handle exceptions, right, for individual devices. You don't want unintended consequences rippling out. So to apply a policy to just one specific device and only that device, you basically bypass the shared stuff from the group. The cleanest way, the most effective solution here, is to create that policy directly on the target firewall itself. Then you commit it locally, just on that one box.
Okay, so you sidestep the group inheritance for that specific rule.
Exactly. It ensures the policy lives only on that device. You get that necessary granular control without messing up the wider group settings. It's critical for those, unique situations where one device just needs something different.
So it's finding that balance then between the power of central management and the need for local flexibility. Makes sense. Are there common ways people trip up on this? Pitfalls?
Oh, definitely. A really common mistake is trying to shoehorn everything into a device group template, even unique requirements. People might try to use complex tags or variables, but if you're not careful, a policy meant for one firewall can accidentally get pushed wider if applied incorrectly at the group level. And that could, break services or even open up holes on other firewalls unintentionally. Understanding when to just go local is really key.
That's a super important distinction.
Yeah.
Now, let's switch gears a bit. Let's talk site-to-site VPNs, virtual private networks, those secure tunnels connecting offices or, cloud environments over the internet. Absolutely vital.
Bread and butter networking, yeah.
So an admin needs to set up a VPN tunnel between two Palo Alto Networks firewalls.
Yeah.
Simple setup. Both ends have a static IP address, and they have to use the same pre-shared key for authentication. The question is asking for the two absolute essential settings needed to get this tunnel up and running. What are they?
Right. For this kind of basic common VPN setup, static IPs, pre-shared key, these two settings are the foundation. First, you absolutely have to define the peer's static IP address. Where do you do that? And the IKE gateway configuration. The IKE gateway, Internet Key Exchange Gateway, that's basically where your firewall learns where the other end of the tunnel is. It's partner.
Okay, so telling it who to talk to.
Precisely. Without that, it's shouting into the void. Second, for the authentication part, you must set the peer authentication method to pre-shared key. And then, crucially, you enter the exact same identical key on both firewalls.
This to match perfectly.
Exactly. If those keys are even slightly different, authentication fails. No tunnel. Simple as that. It's all about that mutual, secure identification. The firewalls need to trust each other.
Makes sense. Simple configuration points, but absolutely non-negotiable for the connection.
Mm-hmm.
Okay, let's dive inside the network now. Internal routing. Specifically, Inter-VLAN routing. So picture an engineer who's set up Inter-VLAN routing on a single firewall, but they're using multiple virtual routers inside that firewall.
Right, segmenting routing domains within the same box.
Yeah. And they need a service route. They need to direct traffic for one specific service, let's say syslog traffic, from one virtual router to a particular destination. How do you make sure just that syslog traffic takes the right path without messing up general routing?
Yeah, this gets into some nice granular routing control, essential when you're segmenting networks with virtual routers, or VRs, because each VR is like its own independent routing table, right? So you often need to steer specific types of traffic, like management traffic or logging, without affecting how, say, user web traffic is routed in that same VR or other VRs. By defining a service route within that specific virtual router's configuration, you're giving it explicit instructions. You're saying, okay, for traffic destined for this service, like syslog, send it this way to this next hop or interface.
So it's very targeted.
Exactly. It's typically configured as a destination-based service route within the settings for that particular virtual router. It keeps things clean, maintains that segmentation, and ensures critical traffic like logs gets where it needs to go, reliably and directly.
Right. Stops it wandering off or getting stuck somewhere unintended. Good stuff. Now, it's something that impacts both security and the user experience quite directly. SSL forward proxy decryption. A company wants to use this, inspect encrypted traffic to certain website categories. But they're worried. Worried about performance hits and, maybe more importantly, users getting those annoying browser warnings.
Oh, yeah, the dreaded certificate warnings.
Exactly. So what's the absolute key step to minimize performance issues and, crucially, stop those warnings popping up for users when you're basically man-in-the-middling their traffic?
This is a huge point, a really common operational headache when rolling out SSL decryption. So when the firewall does SSL forward proxy decryption, it is, like you said, acting as a man in the middle. It has to. It decrypts the traffic, scans it, then re-encrypts it using its own certificate before sending it to the user.
Okay.
Now, if the user's computer or browser doesn't explicitly trust that certificate the firewall is using to re-encrypt, boom, warning messages.
Because it looks like a potentially dodgy certificate.
Exactly. The browser flags it, hey, this isn't the original site certificate, which is true. So the absolute key step is to ensure the firewall certificate is trusted by the endpoints. Typically, this means pushing that firewall signing certificate out as a trusted root CA using something like group policy, GPO, for Windows machines, or an MDM solution for mobile devices. If you skip this step, you get constant help desk calls, frustrated users, and people just clicking proceed anyway, which kind of defeats the purpose of the enhanced security inspection.
Nobody wants those big red screens.
Yeah,
okay. So getting that certificate trusted across the board is absolutely paramount for this to work smoothly. So sticking with SSL forward proxy decryption, beyond getting the certificate trusted, what are the two fundamental components the firewall itself needs to actually perform the decryption and re-encryption process correctly?
Right. These are the core building blocks for the mechanism itself. First, you absolutely need an SSL decryption profile. This is essentially the policy part. It's where you define what traffic should actually be decrypted. Decrypt traffic going to social media sites, or maybe do not decrypt traffic to banking sites. It sets the rules of engagement.
Okay, so the what to decrypt policy.
Exactly. Second, you need two specific types of certificates on the firewall itself: a forward trust certificate and a forward untrust certificate. The firewall uses these to dynamically generate new certificates on the fly for the websites users are visiting after it decrypts the original traffic. It uses the forward trust certificate to re-sign traffic for sites it deems trustworthy based on the original certificate, and it uses the forward untrust certificate for sites whose original certificates are maybe expired or self-signed or generally untrusted.
So it can maintain the trust chain for good sites, but signal problems for bad ones.
Precisely. It allows the firewall to either preserve that chain of trust or intentionally break it in a controlled way, all while presenting a certificate to the user's browser that it hopefully recognizes because you pushed out the root cert earlier.
Got it. So the decryption profile is the what, and those forward trust and trust certificates are the cryptographic tools for the how of the re-encryption.
Yeah.
Very cool. Wow. Given how specific these solutions are that we talked about today, managing configurations, directing traffic flow in very precise ways, how does getting deeply familiar with these exact technical requirements prepare you as a network professional, not just for the problems defined in a practice question or a textbook, but for adapting to completely new threats, unforeseen network challenges, the kind of stuff that, well, definitely doesn't come with a multiple choice answer, something to think about?